So this is the concept of left hand and right hand limit of the function. Whenever your x approaches to a from the left side, then in that case the limit is called left hand limit. Hello my dear students, I hope you are having a nice day. I welcome you all at my channel Prime Math. In today's lecture we are going to start a new chapter, Continuity and Differentiability. The book that I am following here, the NCERT. My name is Azmat and I am working as a lecturer in mathematics in government sector. The first topic of this chapter is continuity. But before going to start continuity, I will revise the concept of left hand, right hand limit of function, the existence criteria of limit of function. In today's lecture, we will also discuss the graphical and numerical concept of limits of function. Although this concept you have already been taught in your class 11th mathematics, but in today's lecture we will just revise all of these topics. So let us start from the real number. Suppose we start our discussion from a real number x is equal to 2. Suppose this is my real number x is equal to 2. You can move towards x is equal to 2 from two directions. Either you can move from left. So this is my real line R and here x is equal to 2. You can move towards x is equal to 2 either from your left side and or from right side. These are the two ways. But when you move towards x is equal to 2 from your left side, all of the values that approach x is equal to 2 will be less than 2. Suppose you can take here number 1.97, 1.98, 1.99, 1.9999, and you can increase the number of 9 here to move towards x is equal to 2. Now you can observe that all of these values are on the left side of x is equal to 2 but less than 2. These values are nearly close to x is equal to 2 but these values are always less than x is equal to 2. Similarly, you can take some values from the right side of x is equal to 2. Suppose you take here 2.001, you take 2.001, 2.01, 2.1. These are all values are greater than x is equal to 2. Although these values are nearly close to x is equal to 2, but these values are always greater than x is equal to 2. Now let us suppose a real valued function f of x. Suppose my function f of x is, for our convenience I am just assuming a very easiest function like a linear function x plus 5. Now if you determine the values of the function on the base of all those values of x which are on the left side of x is equal to 2, then these values have output at x is equal to 1.97, x is equal to 9.7, your function has a value 1.97 is equal to, when you add 1.97 with 5, this becomes 6.97. If you put x is equal to 1.98 here, this value give 1.98 is equal to, this become 6.98. When you add 1.99, this becomes 6.99. When you put 1.999, this answer is 6.999, up to so on. And if you find the value of the function exactly at x is equal to 2, then f of 2 is equal to 7. Similarly, if you determine the value of the function on the base of all those values which are on the right side of x is equal to 2, then the output values are, suppose you put 2.01, 2.0001, the value of the function is 7.0001. If you put 2.01, 2.001, the value of your function is 7.001. Similarly, if you put 2.01, your value is 7.01. Lastly, if you put 2.1, your value is 7.1. Now from this table you can observe that whenever you move towards x is equal to 2, the value of your function move towards 7. Similarly, if you move towards x is equal to 2 from the right side, then again your values approaches to 2 from right side. So I can say that if you determine the values of the function on the base of all those values of x which are less than x is equal to 2, these values 6.97, 6.98, 6.99 up to around 6.999, these values are actually called the left hand limiting value of the function. Similarly, when you calculate the value of the function on the base of all those values of x which are greater than x is equal to 2, then these values 7.0001, 7.001, 7.01, 7.1, these are also called the limiting value of the function, but these are the right hand limiting value of the function. So actually what is the left hand limit and right hand limit of the function, and how can I define in this particular example? So whenever if we determine the value of function on the base values of x is equal to 2 which are close to x is equal to 2 but are less than 2, these values represent left hand limiting value of function. Similarly, you can write, when we determine the value of the function on the base of values of x is equal to 2 which are close to x is equal to 2 but are greater than 2, then these values represent the right hand limiting value of the functions. So actually what is the left hand and right hand limit in this particular example? Suppose one student says the limiting value of the function should be 6.999 and one of the students says the limiting value should be 7.001. Actually, whenever you move towards or approaches to x is equal to 2, your value of the function approaches to 7 from either sides, left or right. So we can say safely the limiting value, either it is left or right, the limiting value of the function is here. Limit x approaches to f of x is equal to 7. So the left hand and the right hand limit of the function in this case is 7. Now I define the left hand and right hand limit of the function for any real number x. Suppose x is any real number. X is any real number. Suppose x is equal to a, and f is a real valued function. F is a real valued function. A function f is called real valued function if its range is real number. Mean to say its output, its answers are real numbers. Suppose x is any real number a and f is a real valued function defined in the neighborhood of x is equal to a. Defined in the neighborhood of x is equal to a. Neighborhood of x is equal to a mean those values which are very nearly close to a, either from left or right. Like in case of x is equal to 2, the values are 1.99, 1.999, tetra 9, 2.0001, 2.001. All of these values actually represent the neighborhood of x is equal to 2. So neighborhood of x is equal to 2 mean all those values which are nearly close to x is equal to a. Then, and this is possible that the function is itself undefined at x is equal to 2. Then the left hand limit at x is equal to a is denoted by limit x approaches to a negative f of x. This is the notation for the left hand limit. Similarly, the notation for the right hand limit at x is equal to a is limit x approaches to a positive f of x. Now suppose that whenever your x approaches to a from the left side, mean to say x is very nearly close to a but it is always less than x is equal to a, then whenever your x approaches to a from left side, mean to say x is less than a, and your real valued function f of x approaches to some real number L1, then L1 is called the left hand limit of the function. Similarly, if you say your real number x approaches to a but x is greater than a, then in this case suppose your function f of x approaches to some real number L2, then it is called the right hand limit of the function, that is L2. So this is the concept of left hand and right hand limit of the function. Whenever your x approaches to a from the left side, then in that case the limit is called left hand limit. Whenever your x approaches to a from the right side, then the limit in that case is called right hand limit. Now what is the criteria of existence criteria of limit of function? We say that the limit of the function exists if left hand limit of the function is equal to right hand limit of the function. If both of the limits exist and they are equal, then we say that the limit of the function exists. Here it may be noted that the left hand, either it is left hand or it is right hand limit, the limit will exist only if its answer is some real number L1 or L2. In case suppose you evaluate the limit of the function and it becomes infinity, then we cannot say that the limit of the function exists. So for the existence of limit of function, both of left hand and right hand limit should be finite and they are also equal. then we say that the final limit of the function exists. Now, what is the graphical and numerical concept? We start from with a very simple example. And one of the most important thing that you can notice here, the idea of left hand and right hand limit exists only for piecewise function. A function which is defined with two or more rules is called piecewise function. For example, the function that I am going to write, it is one of the piecewise function. For example, I write f of x is equal to, this function has a two parts. Its value is 1 when your x is less than or equal to 0. Its value is 2 if your x is greater than 0. I have to check is limit of the function at x equal to 0. That I will write as this can be read as limit of the function whenever x approaches to 0 exist. Does the limit exist or not at x is equal to 0? So in this case I will evaluate the left hand and right hand limit of the function. Left hand limit at x is equal to 0. The function has the two parts. In first part function the values of x are less than 0, less than or equal to 0, and in the second part x is greater than 0. Left hand limit, to evaluate left hand limit at x is equal to 0 mean you have to pick that part of the function in which your x is less than 0. So this is our first part in which x is less than 0. So the left hand limit of the function here denoted by limit x approaches to 0 minus f of x. What is the value of the limit of the function? This is equal to 1. So this, as 1 is finite real number, so I can say that the left hand limit of the function exists and it is equal to 1. See, now I evaluate the right hand limit of the function. Right hand limit of f at x is equal to 0. The right hand limit of the function is denoted as limit x approaches to 0 positive f of x. Now you have to pick that part of the function in which x is greater than 0. X is greater than 0 in second part and the value of the function in this part is 2. So the right hand limit is 2. As you can see here, the right hand limit is also a finite real number, that is 2. So the right hand limit also exists here. But is the limit of this whole function, this complete function exist? The answer is no, because you can notice that the left hand limit of the function is not equal to right hand limit of the function. So we can say that the limit of the function does not exist. Limit x approaches to 0 f of x does not exist. Now if you draw the graph of this function, then from the graph you can easily notice that the limit of the function does not exist. Okay. To draw the graph of the function, firstly we make x-axis and y-axis. This is my x-axis The graph has the two parts. When your x is less than or equal to 0 mean when your x is negative. When your x lies on the left side of x is equal to 0. Your value of the function is 1. Value of the function mean y, value of y is equal to 1. Suppose this height represent y is equal to 1. It means the graph in this part is a straight line. This is a straight line, y is equal to 1 when your x is equal to 0. Because in this part 0 is also included. So this will be a solid dot. Now on the right side of x is equal to 0, the value of the function is 2, mean to say value of y is 2. Suppose this is y is equal to 1, this height is y is equal to 2. Now in this part where your x is greater than 0, the height of the function is y is equal to 2 here, and the height of the function is y is equal to 1. Now it is important that because x is equal to 0 is not included here, because this part has a no equality sign. Equality sign is present in the first part. So we draw a a circle here. Now graphically you can notice that the graph of the function has a jump. Jump mean graphically we say that limit of function exists if the height of function remain same either from left or right. So you can notice that the height of the function in both parts is not same. On the right side it has a height y is equal to 2, on the left side it has a height y is equal to 1. So in simple we say that this graph has a jump, has a gap. Its y values are not same, its height is not same. So graphically I can say that this function, the limit of this function does not exist without calculating numerically. Next we take another example. Suppose now I write our function as my function is f of x is equal to 1 if x is non-zero and its value is 2 if x is equal to 0. Again we have to evaluate does the limit of the function at x is equal to 0 exist or not. Okay. The first part is x not equal to 0. X not equal to 0 mean, my dear students, it has a two meanings. In this case, your x is less than 0 or x is greater than 0. Whenever you say x is not equal to 0, it means either x is greater than 0 or either it is less than 0. So to evaluate the left hand limit or right hand limit of the function, you will use only the first part. The second part will not use here. So your left hand limit in this case is equal to your right hand limit because when you evaluate left hand limit at x is equal to 0, which is denoted as this is equal to 1, because your function is same in both parts, either you take x less than 0 or you take x greater than 0. In both parts you will pick the same function. That's why left and right hand limit will be same here. That is equal to 1. And 1 is finite real number, so I can say that the limit of the function exists. Its left hand limit is also 1, right hand limit is also 1. So the limit of the function is exist. So the limit of the function exists. Now if you draw the graph of this function, whenever your x is equal to 0, your y is 2. Suppose this height is y is equal to 2 here. So this is a point y is equal to 2 here. x0, y2. x0, y2. So this is just a dot. But when your x is not equal to 0, you will move, you can move left and right both at x is equal to 0. So if you move to the right side of x is equal to 0, mean to say x is equal to 0, this height is y is equal to 1. If you move to the left of x is equal to 0, your height is again y is equal to 1. But because here x is equal to 0 is not included, so I will take here a circle, that is whole. But there is no problem. The whole matter in the case of continuity, that we will discuss inshallah in the next lecture. Now from this graph you can notice that either you see the graph from the left or the right, the value of the function is, the height of the function is same, that is 1 unit. So we can say that graphically this graph, this graph shows that the limit of the function exists at x is equal to 0. So now I hope you have a clear understanding of left hand and right hand limit of the function. Next, I am writing a function in which there is no need to find left hand or right hand limit of the function. Like if you take a polynomial function, suppose my function f of x is equal to x square plus 1. I have to evaluate the limit of the function at x is equal to 2. So there is no need to find left hand or right hand limit of the function because this is not a piecewise function, this is just a single function. So in this function you will directly evaluate the value of the function, limit of the function, limit x approaches to 2, limit x approaches to 2, x square plus 1. This is equal to 2 square plus 1, which is equal to 5. So the concept of left hand and right hand limit will matter if your function is piecewise function. Similarly, one of the most important function is the absolute value function. You know, the absolute value function f of x, x absolute minus x. If x is less than 0, this is positive x. If x is greater than equal to 0. So this is your assignment. You have to evaluate the left hand and right hand limit of the function at x is equal to 0 and message me whether the limit of the function at x is equal to 0 exists or not. So I will wait your comment. So I hope now you have a clear understanding of the limit of the function. Inshallah, in the next lecture we will discuss the brief concept of continuity. If you find my video helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care.